Hi, so I'm Dr. Howard. I am an analytical chemist, and I work a lot with the Earth and Environmental Science Department here, running samples for them, looking at nutrients in water samples. So we're often interested in monitoring nutrients in natural water systems to ensure that the levels don't get too high. Because due to runoff and some other sources, we can actually end up with high nutrient levels, which is bad for the ecosystem, and can actually reach hazardous levels. So I'm going to demonstrate the use of some water monitoring tests that actually come in a very simple sample kit, portable sample kit. So you can actually take these out, collect your water samples, and they're really straightforward tests. Most things are prepackaged in pill form, and so they're very convenient, and the results are really easy to interpret. From a pond, we generally want to avoid getting surface water. There's stuff that floats on top, and so we want to get the opening of our container below the water before we actually tilt it, so that we can actually start collecting our sample. So we put it in straight down and make sure that it's completely submerged before we tilt it to the side. And let our sample get in there. This is a little bit low. It's a little bit shallow, but. And so generally you want to get a fairly large sample just to get a good representative sample, but you can always take multiple small samples as well. And then I usually try and label it as soon as so I usually have labeling equipment comes out with me so that I can label things right after I collect them before I take them back to the lab for analysis, so I can identify them easily. So the first test we're going to run is a pH test. So we're going to, we just need to fill our test tube. You can pour it in if you're comfortable doing that, or you can use a pipette to make sure you've got enough solution in there. Of course, it might take a few. So make sure we have plenty of solution. And then we have our wide range pH test. So we can just take one of the tablets, drop it in. And then we're just going to invert until our tablet dissolves. And so you can see that we are generally probably just between 7 and 8. But again, it's pretty simple test. And so 7 and 8 seems like a pretty healthy place to be because it's neutral. So the next test we're going to do is a dissolved oxygen test, and the optimum levels are dependent on temperature, so we want to make sure that we measure temperature when we do our DO test. So you want to submerge our thermometer, and I'm holding it at the 40-degree end because I'm pretty sure this is well below 40 degrees. Submerge it into the water. And then see where we are on a nice day like today. So we're at about 26 degrees. And so then we're going to do our dissolved oxygen test. It's a fairly simple test. We want to, one thing about the dissolved oxygen test is that we actually want to make sure that we are filling our container all the way to the top. So it's important that you don't have any oxygen at the top of the vial. So we're going to fill it all the way to the brim, and then we're going to add our tablet, so it's going to overflow. So I suggest you have a secondary container you can put it in, so that you're not going to be getting wet tables if you're working with kids. So then we're going to take our dissolved oxygen tablet, and we actually put in 2 of these. One. Two. And then we're going to cap it off. Again, you're going to have some overflow, but that's a good thing. And then we want to dissolve it. It takes about 4 minutes for the tablets to fully dissolve. And then we have to wait for another 5 minutes for the color to develop. So hopefully we'll get some time lapse from there. All right, so we've waited the time for the color to develop, and so we see that we're at about 4 ppm for our dissolved oxygen. And we had measured 26 degrees. And so when we take a look at our chart, 26 degrees at 4 ppm means we're at about a 49% saturation level for the water, which is not bad. What we do is for nitrate in our water, so this is an indicator of nutrient levels. You're going to find this in fertilizers and other sources of that participate in our nitrogen cycle. So again, I'm just filling up to get a good sample level. So we want to do about 5 for this one. So I've got it at the 5 milliliter mark. And then we're going to add our test sample, our test tab. If I can get it out of there. So we have our test tab for nitrate. I'll drop that in there. And then we actually want to protect this one from light during the process. So I'm going to pop the cap on there and put it in the protective sleeve that comes with the kit. So I'll slide our tube in there. And then we're going to shake it to dissolve the tablet. And this takes about 2 minutes. And then once this tablet is dissolved, we wait for another 5 to let the color develop before we pull it out and expose it to the light. And then we'll compare it to our nitrate chart. So we dissolved our tablet by shaking it for about 2 minutes, and then we waited for 5 minutes so that the color could develop for the nitrate test. And what we see is actually what we want to see, is that we are actually, the yellow color is mostly from the pond water. It's a little bit yellow, but we really don't have a significant pink tint at all. And even if we do, we're well below the 5 ppm, and having any nitrate is not really good. So we want to be below 5 ppm. 5 ppm is fair level. 20 or 40, if it showed up really pink, you'd be in a bad shape. The nutrients would be way too high. And so what we want to see is less than 5 ppm, ideally. Okay, so now we're going to test for phosphates. So for the phosphate test, using this kit, we want 10 milliliters of water. Fill up all the way to our 10 milliliter line. And we get our little phosphate test tablet. Cap it, and then we're going to invert until the tablet dissolves. And then again, we have to wait for the color to develop. So once the tablet dissolves, we wait for about 5 minutes to get a color development. All right, so we've let our color develop for our phosphate test. And so when we compare to the chart, We are down around 1 ppm or less, which is where we want to be. That's an excellent level. Once we start getting up above 2 ppm toward 4, we're starting to get to the point that the nutrients are too high and your area is at risk of eutrophication. So. Pond water for the most part, so we're going to try running some of the pond water through potting soil that has fertilizer in it, and so then we can retest our samples and see if we've increased the levels of nitrate and phosphate to simulate runoff potentially from gardens. See how. So I've just got potting soil and some filter paper. You can easily use coffee filters. They'll actually probably work better than this because this is draining pretty slow. Looks like I have a bit of potting soil in my water too. I just want to make sure we have enough to run the tests. All right, so we let our water run through. All right, so now I need 5 milliliters for the nitrate test. And then we want 10 milliliters for the phosphate test. All right, so the nitrate test, I need my sleeve, caps. So we'll start with the nitrate first. It takes 2 minutes to dissolve the tablet. I'm going to cap it, and put it in the sleeve to protect it from light. I'll continue shaking that up some more shortly. And we'll go ahead and get the phosphate test started as well, because it takes a little bit of time to dissolve, and they both take 5 minutes to develop color. Alright, so invert, shake, sure, either is fine. Alright, so we allowed our tests to develop their color. And so you can see our phosphate is pretty intense, and our nitrate is significantly higher than it was before. So the nitrate is actually showing up potentially above the 40 ppm level from the potting soil. So we picked up a lot of nitrogen, which isn't surprising. Potting soils typically have a lot of nutrients in the as nitrogen, so you have high nitrate levels. And phosphate, we are up at 4 ppm or higher. Feel pretty confident with that, and again, that's up at the eutrophic. You're up in the eutrophic region there. So if you get tests that look like this out of any natural water system, you're going to have some massive algal blooms in the summer and the spring. So